This shed's been here for about 2 years now. I'll just try and take you around it, take you some of the good things, some of the bad things, some of the things I'd do differently if I redid this again. It's actually got a proper rubber roof, so it's a one-piece rubber roof that covers the entire surface area, and then it's been folded down, and down here and underneath, it's been bonded around, and then this has been put on top, and this has been put on top. We've got some holes here cut into the soffits, and basically what these do, on the actual roof there'll be a wooden beam here somewhere and one this side somewhere, and we've got a hole here in between, same on the other side, to let the air go in here. Make sure that the underside of the actual roof material keeps dry in the worst case scenario. I think when you come to design the shed, one of the most important things is how big you want the shed to be, and I think if I did this again, I'd have actually used this space next door and made the shed a lot longer. One of the good things with the shed, we've got this material on the outside, and it's about 35mm thick, and it's very good quality. It's got like a double overlap joint, so it won't let any water in, which is good. When you come to first design it, the first thing you want to do is make sure that the size of the shed is correct, and then you want to look at where you're going to get the door and the window from. So the window I got from eBay. It's a house window, double glazed, that I paid about £10 for. The door itself, again, I got from eBay. Had to refinish it, but I paid about £50 for it. And then I actually cut the door, the top of the door, so it's a bit shorter than a normal door. I didn't want the overall height of the shed at the very top to be too high. I wanted to sort of keep it in line with what next door's is. You can go up to about 2.5 meters max when it's within a meter of the boundary. I think it's 3.5 if you're within, if you're not within the meter of the boundary. I actually dug along the grass for the electrics, and then brought the electrics in through the side of the shed, and then at the back we've got a water butt. So we've got the water butt, a lot of spiders this time of year, and then we've got the guttering that runs along the back, and all the water goes across there into here, and then into the water butt, and any excess comes out at the bottom. So there's a quick picture down the back. One of the problems with the guttering, it never actually sealed very well around the joints, so I actually bond it together, which wasn't the best, but at least it works properly now. Right, so let's go inside. There's a couple of different ways you can do the door. In this case, I didn't do it how you do it on like a house. So on a house, you'd have the bottom of the door sitting on here, so the water would come off of this and onto the floor. In this case, what I've done, I've gone the opposite way, so ceiling wise it's not quite so good, but from an air point of view it's very good. So it seals around this gap all the way around, so when you close it, it's doesn't let the air in, so that's what I was after. If you're going to use this method, you want to make sure you've got a bit more overhang on the roof, so most of the water doesn't go down the door and try and get underneath. This is actually sloped slightly to let it fall off this way. I think one of the big things for the shed is the actual base. So here I did a bespoke concrete base, and I sat the framing on the outside of the concrete itself, so any water that comes off the shed, it falls off here and straight onto the floor rather than going onto the slab itself. So the outer framing goes on the outer of the concrete base. And I think a concrete base is definitely the right thing to do, and you want to be aiming for something like 4, 5, 6 inches thick, depending on the size of the shed. got the angle of the roof. It's probably difficult to see here, but it's about 6 degrees coming down, sloping down. I probably could have got away with a little bit less, maybe 4 degrees. Might have given me a bit more space inside. But yeah, I think maybe 4 degrees would have been better. Chose to go with this style of roof because it gives me the height at the front of the shed for the door, basically. I put these corner pieces in here just to cover the corners up, basically protect the corners, and also put the same material along the top. One of the mistakes I made is this material itself, this is hardwood and this is softwood. So the main structure is softwood and this structure here is hardwood, and the hardwood doesn't take the oil so well as the softwood. So you really need to use a yacht varnish on this, and you really want to be using an oil on this. Initially I put oil on this as well, and it didn't take the oil very well, and it started to corrode a bit and go black in places. I'm sure if I'd have put the yacht varnish on that to start with, it wouldn't have gone black in some places. The oil works really well on the softwood, but not on the hardwood. I made the same mistake around the window as well, but I actually changed this recently, and I've put in some pressure treated 2B4, and I cut some bits off it, and I've also sloped this slightly to let the water run off, because the hardwood here actually started to go quite black across the top, so I cut that off and put this in instead. What I should have done, I should have spent a bit more time on the on trying to seal it around here. It's actually quite difficult to seal it and make it look a good job, and I probably should have used the same colour that I used around here as well. This colour matches a lot better than the white. The white's not particularly very good, but it's what I had at the time, so that's why I used the white. Right, so let's go inside. That's better. Right, so got some shelving up here, some shelving up here. I put some lights in, so there's one up here and one up here. Also got electric around the shed. There's also switches, and behind here somewhere you can just see it, there's a consumer unit. It's actually a garage consumer unit, and in there we've got the 6 amp circuit for the lighting and 32 amp for the sockets. There's a socket around here somewhere, probably difficult to see. There's one under here somewhere, and there's another double socket under there, but you can't see it at the moment, and that double socket feeds this socket that we've got here. Yeah, I tend to turn them off when I'm not using them. But the good thing is the floor is really solid, being the concrete base, and we've got the 11mm. All this wood's 11mm thick all the way around, so the roof of the walls are all 11mm thick. And since I made this, it's all been 100% solid. It's really stiff in all directions, and it's not going anywhere, and it's completely watertight. There's no water been coming through or anything. There's 50mm Cellutex underneath here, and the framing's 4-inch, which is just over 100mm. So this is the level I went to model the shed originally. So there's different ways of approaching doing this particular job. You can either go to the nth level degree and model absolutely everything, or design absolutely everything, or you can sort of make it up as you go along. I think it depends on roughly how much you're going to spend to how long you want to spend designing it in the first instance. If it's quite a cheap job, you can probably get away with doing minimal design. If you're going to spend a lot of money and go to the expense of going to get the quality types of wood, and you're going to spend a lot of money, it's better if you design it like this, and then you can order the exact right amount of materials. I'm sure it ends up being a lot cheaper if you design it and you know exactly what's going to happen as you build it. This way you get a lot less surprises. Okay, so let's have a quick look at sort of the levels I went to. Let's turn it off to start with. So let's start with the base. So I think the best way of doing this is to start with a concrete base. I think one of the important things with the base, you need to make sure that the water and the damp can't come up through the concrete. So what you want to do is put a sheet of plastic down first before you pour the concrete onto the plastic. The plastic will stop it getting damp over time and the damp going through to the wood. So we've got the concrete base. If you were going to make it thicker at any one location, I'd probably make it thicker around the outside of the concrete base, on the underside obviously, and this is where the frame would actually sit around the outside. So I've made it so the frame sits on the very outside edge, and this is so that any water runs off and doesn't go onto the base. But yeah, you want to make sure you cover it with a good layer of polythene on the underside to make sure the damp can't come through. And then I started making the framing first. So let's have a quick look what we got. I think it was probably the front frame first. So there we've got the front frame. We've got the door cut out and we've got the window cut out. So in this instance, I didn't know where the roof frame was going to be relative to where the struts are. So on the top here I put 2 layers of wood and connected them together, and that gives enough stiffness between this one and this one, for example. So even if the roof strut comes here, it is plenty strong enough, plenty stiff enough. At this location for the window, I've put extra pieces of studs in, and this stud holds this piece, this stud holds this piece, and then lower down you got this stud which holds this piece, and these are all connected and screwed together. And this is it's very solid, and then the pieces run in this direction, basically all the same material, so it's all 4x2s. So I've got one here and one here. I think I actually put in between something like a 5mm strip to separate these two to make it the same width as this. So this is quite strong in bending in this direction, likewise the same as these, and that's really what you want for your window. And I've used the same method on the door, and this is why I made the shed a particular height. It was so I can get a door ring of this size, and I'm about 5'11", so I made sure I could go through the door without hitting my head or anything, and I could stand up at the front and at the back of the shed without hitting my head. So that's the sort of height I was after. You're allowed up to 2.5 meters, I believe, if you're within a meter of the boundary. I think I mentioned it before. So you just have to be a bit careful you don't go too high. So I've got the front frame here, so I probably made that first, and then we've got the rear frame, so I made the rear frame as well. So I made these as like a sub-assembly, so I got 2 sub-assemblies, and then I made the side frames. So let's have a quick look. Side frames, I've got 2 side frames, and then I connected the side frames to the front and back frames. And then you got something that looks a bit like that. I sloped the roof with a 6-degree angle to let the water all run off the back. Didn't really fancy a flat roof, but the truth is, I've mentioned it before, you could probably get away with about a 4-degree on it instead of 6. Then you might have a bit more space inside for storage. I did actually put some some struts across here, and then ran the electrics on top, and I've got a little video of that coming up in a minute. So it shows you how I put the electrics in. I've not actually modelled them pieces in, didn't really need to. If you look, the framing is sitting on the very outside edge of the concrete, so when you put the cladding on, the water runs off the cladding and it doesn't go onto the concrete. One thing I did do before I actually put all this framing to the concrete, I actually used on the underside here, so it ran all the way around. It was a damp proof course, the same as what you use on brickwork. I ran actually 2 layers of damp proof course around all of this, just in case this did actually let damp through. I didn't want this to stay damp, as it were, so I put some damp proof course, 2 layers all the way around the outside, and that seemed to work really well. There's no actual damp coming through, but it was just in case. All of this wood was pressure treated, and I think it was C16 structural grade. Right, so when you've built the 4 walls, as it were, I think then instead of doing a frame assembly for the roof, I put individual pieces on. It was easier to carry rather than make the roof frame and then try and put it on top. So there we've got the roof frame, which just sits directly on top, and then I've basically drilled holes in here straight through and put some large screws in all the way across, and then I've actually put some hurricane ties on the fronts and backs, so in this location and at this location all the way along. And we've got a slight overhang all the way around. I think if I was doing this again, I would have probably made the overhang a little bit bigger. The size of the concrete is actually 2.3 metres by 3 metres that I made the shed. I think if I was going to do this again, I'd make it a lot bigger. One of the reasons is it doesn't cost a lot more to go a bit bigger, and you're going to use have a lot more space at the end of the day if you go a bit bigger. So I think it sort of pays off having more space, I think. Right, so we've got all the frame. Let's have a quick look. So we've got some cladding. We've got the cladding to go on, and I've also put around the door the same material I've used around here. I've used around the door, and I've put it around the window as well. This was 2x4 cut down, but it was pressure treated to make sure it didn't go black, as it were. The actual framing itself, I've just connected it to the struts as I go along, screwed it through, and I've left this sort of this corner, and what I've done is I've sealed down here on the 4 corners to make sure no water can get in. So it's just got a silicone sealant running all the way down here on the 4 corners, and then I've put some corner pieces on just to protect it. Modelling it this way, I can tell exactly how many runs I need and the lengths of all the pieces and where the cutouts want to go, etc. It's quite accurate. The actual main frame, before I put the cladding on, I actually cut it all to the CAD models within plus or minus 0.5 millimetre. So for example, these lengths, I cut exactly a 6° on here to the length of the CAD model, and then I put all the items together and it worked out pretty much exactly. So it saves all the hassle of you've got a gap here and not here and etc, and it not fitting quite right and all the rest of it. Cutting it to the CAD model actually worked really well. Right, so I've got the cladding on. I didn't go to the nth degree of modelling all the inside and all the insulation and everything else. I just went far enough to make sure that when I were ordering certain items, I was getting the right lengths and material, and I didn't have to go and order any other lengths. This particular wood was quite expensive, and there was like a minimum order quantity on it. So I didn't, I couldn't go and order another 10 metres. It was something like a 100 metre minimum quantity order. So it's quite important I got the lengths right. And after I'd finished it, I'd probably got something like 16-17 metres left. One run, 16-17 metres. It's actually a couple of runs, but But yeah, so it wasn't bad overall. Right, so we've got the roof. So one piece of wood wasn't quite long enough, and here I've used OSB 3 3/4 inch, and I actually stood on the roof when I was doing it all, and I'm quite heavy, and it all worked fine. I've actually put the gaps along here, or the runs along here, and pushed it up against each other, and that comes in accordance with where the beams are. So the gap is where the beam is. So on the inside there's no gaps at all, and where the rear gap is along here is actually after. It's actually, you know, here somewhere, so it's not actually on the inside, which is the way I did it. I think it was a lot better that way than any other way. Right, so we've got the roof on. Basically I used a one-piece rubber, so I put the rubber roof on. And you have to be careful when you put the rubber roof on, because there's like a two-part bonding for the rubber roof. And basically what it is, around the inside, the glue, as it were, is not very strong, and it allows the rubber to expand and contract. But the glue around the outside edges is a lot stronger. So I put the glue on the outside edges and down here and slightly underneath, and bonded it around, and then screwed it as well. But you have to be very careful with the stronger glue that goes around the outside, because you have to leave it something like 15 minutes to cure. And it's always best to leave it that 15 minutes, because while it's curing, it lets off air, and you get lots of air bubbles in the rubber when you try and bond it if you don't leave it that 15 minutes. So that time is quite critical, and obviously you want to make sure it's not raining or anything when you're trying to do this job. When I actually tried to put the rubber on, it was actually not the best weather. It was starting to rain. I was struggling to get it on in time, and things like this. So I did have a few air bubbles in it. You do find that over time, though, the rubber stretches a bit. It seems to shrink a little bit over time, and that pulls a lot of the air bubbles out. Right, so we've got the roof. So that's basically putting the rubber on all the way around and underneath. And then we've got the soffits. Right, so basically what I did here was I've got some holes, as you can see on the actual proper shed itself, and these holes go in between the beams, and it lets air run across here and out the back. So I've got the same on the back, the same holes at the same locations. And basically what I've got is there's an 11mm OSB 3 on the inside and 50mm insulation, and the air runs along the back side of the insulation and make sure that this OSB 3 doesn't get damp at all. And I think that's a good way of doing it. Right, so the soffit is on. We've got the window to put in. So I've got the window, double glazed window that I got from eBay, and basically there's some screw holes which come through here, through here, here and here. The key thing is with this is not to try and over tighten it. I left a 5mm gap all the way around, and I filled it up with expanding foam all the way around the outside, and that's worked quite well. You don't want to over tighten it, otherwise you could crack the glass if you get any movement later on. It's been very stable though, to be fair. So we've got a roof trim that goes around the outside, which looks something like that. I've not got one on the back because I've got a gutter where the water comes off and into the gutter. And we've got the corner trims that went on just to cover the edges. And you can see the shed more from the front, so I've put the overlap, because there's two pieces of wood here, and I've put the overlap so you can't see the joint at the front. I'll put it down the side instead. And that's sort of the level I went to when modelling it and deciding what the sizes were, and I cut all the sizes directly to the model within probably plus or minus half a millimetre, and it all came out really well.